Perfect. All right. Hello, everyone. So in this talk, we're going to discuss what it takes for serverless to become commodity. So hopefully, at one point, we start moving on to other interesting stuff. So to get us started, my name is Nima Kaviani, and I'm an engineer with IBM. And I'm here with my friend Dmitry from Pivotal, who clearly, you can tell, has come from the East Coast. All right. So I think at this point in talk, all of us know the pros about serverless. Obviously, a lot of people want to use serverless and enjoy using serverless because it's easy to manage and it's cost effective. Obviously, it's easy to manage because there is less that you have to care about. And back to Evan's talk, it's cost effective in many ways, particularly saving on the operations cost. On the negative side, however, one of the biggest problems that people deal with when talking about serverless is that they're afraid of getting locked in with a particular vendor. Essentially, the reason is because you're only in charge of a tiny layer for your software. For every other service, you have to rely on the service provider or the cloud platform provider to build your application. So this is to the point that some people, including Alex Polvia of CoreOS, consider serverless as one of the worst and proprietary lock-ins in human history, right? Also, so other people, including Kelsey, acknowledge this. And one way for a lot of companies to try and solve this is by providing an open source layer that can go on top and then would give you the flexibility to migrate from one cloud provider to another if you choose to. So for us to kind of understand what it takes for serverless to become commodity, we started looking at Kubernetes as a good example. Because I think at this point, pretty much everyone agrees that Kubernetes has won the orchestration war. And container as a service is essentially Kubernetes, right? So the question that we started asking ourselves was, okay, what does it take for serverless to become commodity? And who's going to win the serverless war? So we started looking at why Kubernetes was so successful and identified 3 different stakeholders and the reason they actually like Kubernetes a lot. So from a provider's perspective, Kubernetes was very appealing because it was open source and it was IaaS agnostic. So they could contribute to it, they could see what's happening inside, they could take it and deploy it on their infrastructure, right? From an operator's perspective, it was interesting because it offered a declarative model of deployment, which was consistent. So regardless of the type of application that you want to deploy, you need to know the building blocks, and then once you know the building blocks, you put them together, you get your application up and running. So it was very easy to get on board with Kubernetes. And finally, from developers' perspective, it was appealing because it offered a consistent API across all the platforms, right? So it actually allowed them to migrate from one provider to another if they weren't happy with their existing provider. So we decided to actually take these and look at what it takes for a serverless platform to repeat Kubernetes success. What do they need to do, right? And so, the points that I discussed, being open source, IaaS agnostic, consistent deployment model, and consistent API, the first 3 appear to be, satisfied by essentially every serverless platform that's built on top of Kubernetes these days, right? All of them adhere to utilize the API that Kubernetes offers, and essentially there are a lot of open source and IaaS agnostic platforms that can be built on top of Kubernetes. So the one piece that we started looking at was, okay, what is the consistent API that needs to be implemented by a serverless platform for it to be appealing and to be adapted, more generally? And that is basically the discussion in the rest of this talk. So yes, we started looking at the consistent API model. And in order to do that, next slide, in order to do that, we actually started looking at different serverless platforms. And we started looking at different criteria for what the API is supposed to be across these in order to compare and contrast and come up with a final ideal that we think is essential for a serverless platform. So I'm going to hand it to Dmitry.
Hey, So yeah, we'll take a look at the 7 criteria over here and find out what are the different implementations like AWS Lambda, OpenWhisk, OpenFaaS, Kubeless, Knative do. Do note that we're not experts in any of them really, but we did look into different implementations as deeply as we could. We looked at documentation, we played around with some. We do occasionally contribute to Knative. We do use AWS Lambda for a few of our own projects, and of course Nima is from IBM, so he's more familiar with OpenWhisk. But do take the information with a grain of salt, and do let us know if something is incorrect. So let's take a look at number 1, packaging contract. So when we say packaging contract, what we mean is what does the developer need to provide to the platform to run their function, right? So in Lambda, when Lambda first came out, right, they had effectively a zip file as the interface. Nowadays, they gotten a little bit more sophisticated in that area, and they allow you to provide multiple zip files for different for different scenarios, and those being, for example, the base layer, and then I think the final application. OpenWhisk supports custom packaging similar to Lambda, but it also does support OCI image. OpenFaaS, custom packaging that ultimately results in OCI image. Same for Kubeless and Knative. Say it again. There you go. And then Knative, because it's based on Kubernetes, it only supports OCI image. Though I'm sure people who use cloud native build packs and whatnot can ultimately avoid OCI image directly, but really convert into it before giving it to Knative. So let's take a look at the next one. Next one is runtime invocation contract. So we kind of split the system into 2 parts. One part between the platform and the runtime. And runtime, we have this kind of a maybe a wrapper around your application. That's what we call runtime. And so we're going to talk about specifically between the platform and the runtime. So let's dig in. So Lambda, as we found out, actually has runtime pooling Lambda API, right? So this is somewhat different from some of the other implementations where, for example, OpenWhisk allows you or sends a message over HTTP to the end application, right? Which is obviously quite a different implementation, right? OpenFaaS, quite similar. It pushes over HTTP, Kubeless again. And with Knative, there is actually no runtime wrapper, right? You have your application directly in OCI image, and it directly accepts whatever the request is coming in. So we're going to also talk a little bit more about that in the next slide. Some of the other, I think earlier in the talks about OpenFaaS, it was mentioned that you can, depending how much functionality you want to reuse from the platform, you can bypass some of the layers. And I'm sure some of these other implementations allow you also to remove some of the, built-in default processing. But that's our current summary of this. So between the runtime and application, right? So if we imagine that this runtime thing is a wrapper around your application, what does it take for the runtime to actually pass the information down to your function? So in Lambda, if you look into it, into the underlying libraries and SDKs that they provide, there is some custom JSON enveloping going on. With OpenWhisk, there is 2 options. There is a JSON envelope, which I believe is custom for OpenWhisk, and then you can also just directly accept HTTP stream as if it's coming from your regular load balancer. OpenFaaS, we saw that there is a standard in, standard out. Again, correct if I'm wrong. No? Tell us what it is. Okay. Yeah. So sounds like we should have talked to OpenFaaS maintainers a little bit deeper. We we didn't take a look at OpenFast too much besides the docs. Like I said, not an expert in a lot of these things, but it sounds like HTTP acts as a basis of it, and I'm assuming there is a watchdog or some other mechanism that translates it into standard in, standard out for some of the stuff. No? Mm-hmm. Interesting. So I guess based on my understanding, some of the examples did show that you can just write some kind of a bash function or whatnot that just accepts some, input-output kind of a thing, but maybe that wasn't it. Right. So that's what we're kind of talking about, this wrapper, right? That. But you don't have to use that wrapper. Right, but this is exactly what we're talking about. So runtime is that potentially optional wrapper, right, that ultimately results in what the end user. And it looks like, there you go, we're back. So this is exactly what we're talking about. Runtime is that potentially optional wrapper that wraps the application, right? So ultimately, yes, it may be built inside with, HTTP and whatnot, right? But from the end user, let's say their proposed ways to do standard in, standard out.
Same things as Knative, but maybe also has a standard.
Fair enough. Okay. So Knative, as you just mentioned, so Knative doesn't do any kind of wrapping to our knowledge. HTTP1, HTTP2, and cloud events for Knative eventing was some of the technologies that we've seen that are used. And then I guess one interesting thing that Knative and Lambda we saw was that with Lambda, you do get to use a lot of the SDKs and I guess proprietary Lambda technology to wrap your application around. With Knative, it's slightly more familiar tech to an average web developer, right? That you don't have to really write any kind of wrappers, or you don't have to use any kind of additional libraries. You can just use directly, let's say, in Golang, NetHTTP, or whatever else it may be, right? So that's one aspect to consider. Execution model. Lambda, we saw that it was offering synchronous and asynchronous functionality. We saw that there is, personally we've used synchronous functionality in most of the cases, but we did observe that you can configure some of this functionality to actually run asynchronously. For OpenWhisk, we have synchronous, asynchronous as well. OpenFast also supports that, so that's kubeless. However, in Knative, we've only seen synchronous functionality being supported by default. Now, obviously, anything that's synchronous, you can kick off asynchronous tasks within your synchronous request and maybe fully complete it. But with that comes interesting questions of when does your function terminate and how you can manage it over time, or visibility into that stuff. I believe Nima actually made some issues to discuss that further with the Knative community. I don't quite know where that is at this point. Let's see what else we got. Retry model. With retry model, it was quite actually interesting. Most of the things did not support any kind of a built-in platform-provided retry, with one exception of Lambda and OpenFast. With Lambda, though, it wasn't retries based on if the platform is failing. It was mostly retries based on your application logic. We don't have any kind of retries on, I guess, asynchronous workloads. Well, no asynchronous workloads, no retries. So that was kind of an interesting observation there. Yes, question.
I'm just curious, since you mentioned cloud events, so Knative for you includes eventing, and if it includes eventing, would that mean there is asynchronous and retry?
Repeat the question.
So the question was, since we mentioned cloud events, does that mean that we're also putting Knative eventing and Knative serving under the under this title of Knative? Yes and no. So again, none of this is specific with particular examples, but we did see that Knative is aware that cloud events is an emerging standard, so it is being used in one part of the system, but not necessarily in other. We mostly focus though on Knative serving in this case.
And also another thing that I add, so even though obviously you can implement async and do retries with cloud events and Knative eventing, there is no standard for how you do it. Like there is no general accepted community way that, okay, this is how you do async with Knative. Whereas with the other ones, there is like a very clear way. For example, with Lambda, you can just pass the invocation type, and that sets it, right?
All right, concurrency model and auto-scaling. So Lambda is mostly request-based, and given that they're auto-scaling based on a queue length, again, not all Lambda engineers, so they might be doing some more magic stuff behind the scenes. That's what we observed based on APIs and usage. OpenWhisk was mostly request-based. OpenFast, request-based, and resource-based. And when we mention resource-based, what we mean here is based on CPU and all kinds of other potentially custom metrics. Sure. And
So resource-based, basically HPA, right?
Right.
Yeah. So everything is a scale to zero except for the other one is not a scale to zero, essentially.
So for kubeless, request-based and resource-based, it appears that kubeless did not support scale to zero, whereas all of the other offerings in the slide did support it. And finally, Knative offers request-based and resource-based via HPA and KPA extensions. So finally, I think this is the last one, traffic splitting. So for traffic splitting, it seems that Lambda decided to go with offering a first class in their API, first class support for app revisions. OpenWhisk did not have such functionality, and I think it requires external load balancing to separate between different app revisions. So effectively, you end up deploying multiple applications, not iterating on the same application. For OpenFast, external service mesh was the choice, seemed to be the choice. Any corrections there? Say it again?
Yeah, using SMI.
Okay, perfect. So using service mesh interface, that came out of, I think, this. And then kubeless, same kind of a situation, external service mesh. And finally, Knative, we have built-in functionality done through revisions. So revision is a copy of your application over time. And Knative also supports some configuration, some first-class routing specific objects, CRDs, that could be used to integrate with whatever you want to integrate with. So, we've talked about some of these platforms that we're all aware of. We've talked about some of the aspects of those platforms. So under your seats, there's a clicker where you can pick up and start voting for some of the things that we're going to go in slides. No? Nobody looked. I checked. Nobody looked. Okay, so one of the things that Nima and I wanted to do is we wanted to go through a few different questions and actually ask the audience to vote as we go along through some of the slides, and obviously by raising hands. And so let's dig into some of this stuff. And I think, Nima, you go first.
Sure. So obviously, like Dmitry said, like if we give this presentation in any other conference, we have some opinions or some ideas about, what is the design for a serverless platform. But here, because there's a lot of experts in the room, we thought we would turn it over and ask you guys what you think would be the proper API design for serverless. So the first thing that we started with packaging contract. So as we mentioned, there are a number of choices for packaging contract, like OCI images, custom packaging, and custom packaging into OCI images, right? So just by a show of hand, who thinks the proper packaging contract or packaging contract would be OCI images? Okay. Custom packaging of zip files and stuff? Okay, one person. Custom packaging into OCI images. Okay, great. What is it? 1 and 3. Yeah. Yeah, so the perfect option, combination of OCI images and custom packaging into OCI images. Sure. So we thought, like our opinion was OCI images. And the main reason was that, well, obviously you can do custom packaging into OCI images, but then you'll have to make your users to also customize their OCI images and provide them potentially if there's a huge dependency for your application, huge set of dependencies for your application. Because otherwise, you can rely on KPack or some other technologies or build packs to kind of bring it into the OCI image. But essentially, it feels like it might be slightly easier for people to just take care of the end-to-end and provide you with one OCI image.
Maybe to clarify on that is, we don't necessarily think that the platform itself should be responsible for that, but rather maybe there's another better tool that deals with that conversion if such conversion is desired to be exposed to the user.
Right.
I think it depends on the user you're trying, the platform. So who is the end user? So for some cases, like for example, for some of the platforms who are trying to break the barrier for the developer who's, I don't know, used to do old style non-Knative stuff, for him it's very hard to tell him provide you that. He just needs to run your code file and everything will work out. Repeat the question. I think it depends on the layer.
Right, so what's been said for people who didn't hear is that it's really a question of what kind of user you're targeting with your platform, right? Some users are very comfortable with doing, let's say, traditional non-OCI artifact delivery to their platform, so they're happy in that world, right? Versus maybe a newer Kubernetes-based systems, right? They really prefer the OCI image-based. Yeah, I think we generally agree. It becomes more of a question, where do you draw the boundary of the serverless platform, right? And at least both of us don't necessarily think that, it's fair to put that functionality into the serverless platform, but we do believe that it's fair to put it into an additional product, maybe on top of that, right? So yeah. All right, so let's take a look at the next one. Runtime invocation contract. So keep in mind that, again, we've defined runtime as that lightweight wrapper around the application, right? It's mostly for convenience, for the end user to be, more potentially familiar with the contract, right? So this piece is really maybe on an implementation detail to the platform, right? So we think there's two options here. There's an option where runtime calls the platform. So this is mostly for style of, let's say, your platform has some kind of an internal queue, right, where individual functions get spun up, let's say, and pull from the platform. And an alternative is platform calls the runtime, right? So that's more similar, let's say, to Knative, where there is a platform component that's smart enough to scale up your function and then send the request to the function. So for number one, any hands? All right, we got two.
Runtime calling platform. 2.
Runtime calling platform.
Platform calling runtime.
All right. So this is a controversial talk. We picked this one. I think, so this is, by the way, I was actually surprised when we were looking at Lambda. We actually deployed a few applications on Lambda and ran it for a while, but we didn't know how exactly it worked. So we looked into it a little bit, and we actually found out there was actually 2 APIs exposed, where actually it's a little bit, like 3 or 4 API endpoints exposed, where individual containers, when they get spun up, they actually say, what's the next request, and then they pull it, and then they work with it. We think it's a little bit more flexible approach. It removes a few problems that you typically end up dealing with if you prefer number 2 for auto-scaling and whatnot. But there's a big downside, right, is that if there is some existing applications that you want to put in this serverless world and they deal with HTTP workloads, right, and they just want to accept the HTTP streams or whatever it may be, right, there is some difficulty there. Now, Lambda, for example, they add some libraries and whatnot to make it easier, right? So once you connect the, let's say, ALB, like we do in our case, with the Lambda and use some additional libraries, you can still do, basic HTTP stuff, but there is some shims involved. Any other thoughts from the audience? Yes.
Evan?
Streaming protocols like HTTP2 may be more difficult to wire in Model 1 than Model 2.
Evan says streaming protocols like HTTP2 might be harder to put into Model 1 than Model 2. Right. That's with the assumption that if you go with Model 1, you do want that higher level HTTP2, right?
So the point is, there's like different types of workloads, and for one particular type of workload that's streaming, obviously Model 1 is not going to work. But if you put that one aside, then the benefits that you get, and I think in the other points or criteria, we're going to get to it, the benefits that you get from Model 1 makes it appealing potentially. And I think we can discuss it in the next slide, right? Oh no, application. Okay, so before we get to that, application invocation contract, right? And the application invocation contract, I think, is the layer that your runtime calls, or basically the layer that your platform uses in order to make data or transfer data to your application, right? So the 3 or the 4 different models that we've seen is that there is like a custom message envelope that can be transferred. Like this is the example with Lambda, for example. You get a JSON envelope from the platform, and your application deals with it. There is the STDN, the standard in and standard out. It happens in some of the platforms, and that the parameters get passed to the application and execute the binary for the application. Or it can be HTTP, similar to what Knative does, basically making a direct call to the application. Or it can be a combination of HTTP and cloud events, basically passing the message, wrapping it in an envelope, and passing it in the form of cloud event into the application, right? So looking at these 4 options, again, like who thinks custom message envelope is a better option?
And keep in mind that application invocation contract we defined as this lightweight wrapper around your function, right? So it's potentially optional, but hopefully the default within that platform.
So custom message envelopes, I saw 1, 2. Standard in, standard out, there's 1. HTTP, yeah, there's a few. And then HTTP and cloud events. There you go. Okay, so for us, we also think that the last one is the better option. Mostly because, piggyback on the previous point that we made about the runtime contract. If your runtime contract actually allows for polling, then the way we thought of the platform is that you actually store that information that comes in, or the request that comes in the form of a package or a cloud event package envelope, and then you keep it and pass it through to your application as you process these requests, right? And for it to be a standard, like cloud event, is potentially more useful because then there is, again, like given level of flexibility between, if you move take your application and move it to a different runtime, you can more easily interact with it. So for the benefit of using the standard cloud event specifications, we thought that it's better than custom package.
All right, we gotta go a little quicker. We have about 5 minutes.
Sure.
So execution model. Some of the platforms offer only synchronous. Some offer both. Some offer, well, I don't think any of them offer just asynchronous. Maybe some do. I'm sure someone does. So what is it? Any hands for just synchronous? Just asynchronous? Both? All right, well, everybody got both. We also think it's both.
Finally, huh?
Retry model. So this one, you can really slice it and dice it all kinds of ways. There is something that could be platform provided, and obviously platform provided also goes in all kinds of various shades of that, right? There is, there could be internal application, internal platform problems that it has to deal with, or it has to be maybe only application-specific retry logic, or alternatively, you just go ahead and leave it to the client, right? So what do you all think? Number 1, any hands? Couple hands? 2? Mostly 2. All right. We picked the other one. The reason we picked the other one is mostly because we think similar to how service meshes work, where they shift some of that responsibility from the end user, from the application writer, right, into this, additional component that you don't really have to think or worry about. We think that the platform can do similar kind of help, or give similar help to the application writer. I don't really think we had any other specific reasons why we picked this one.
Yeah.
All right, what's next?
So concurrency model and auto scaling, obviously the three models that we discussed: pull-based, based on the number of requests; push-based, based on the number of requests; and then resource-based, right? So pull-based, number of requests, Evan. Push-based, and the number of requests. All right. Resource-based. All right. So resource-based, I think HPA and looking at the CPU resources and everything else. I think when we looked at it, again, going back to the runtime that we noticed, and basically if you have this async model enabled, we thought the pull-based based on the number of requests and looking at the queue lengths potentially make it easier for you to scale.
And I think, I guess maybe to even go further than that, we don't necessarily think that it would be that useful to have resource-based scaling if you are able to deal with the, determined based on a queue length, right? Which might be controversial. Yes?
Probably sometimes you need to have a little resource synchronization that will, where you coordinate
Potentially, but then if you have deployed an application that, let's say you've said, hey, this application is single-threaded, it only deals with one request at a time, right? You gave it some initial sizing, right? Maybe that's enough. Not sure. All right, traffic splitting. I think this might be the last one. We have, we kind of decided to I guess, offer two options over here that are not necessarily related to traffic splitting, but really influence traffic splitting. So we thought native app revisions that facilitate traffic splitting would be nice. Or alternatively, independent apps where effectively you have to push your app multiple times to get different versions and then externally deal with how you route to those things. Might be another good option. Thoughts? Number one. Who thinks number one is good? All right, there's a few of them. Number two? Nobody thinks number two. Well, maybe one. All right, we also thought number one is good, given that it gives that flexibility and additional data to the integrator, and also if the platform provides this based on app history and app revisions and easier rollbacks, so that could be easily achieved or more easily achieved. So yeah, questions. That's probably the most controversial slide. And I think we're done. Catch us somewhere out there. Thank you very much.
Thank you. So I don't think that